Right. Today we're going to be looking at static and kinetic friction. These are the different frictions that we're looking at the last video of my static and kinetic friction and the different forces that we're dealing with as well. Right, so I'm going to look at these two formulas over here. Now, looking at this, we can see that the coefficient of static, right, my coefficient of static, as well as multiplied by my normal force should be greater or equal to my my static friction over here. So this has to be greater or equal to this. This can never be less than my static friction. If it is less, then we know that the object would start to move. This would start to move over here if my static friction is overrun. Now, looking at this one over here, I've got kinetic friction. My kinetic friction is going to be my coefficient of kinetic times my normal force over here. And that is going to be my frictional for my kinetic over here. So those are the two. Now I'm going to give you some examples where you would be using this. Right, so your teacher places an 800 gram leather covered book on her wooden desk in your classroom. The coefficient of static friction between the leather and wood is about 0.35. Now you can notice for the value of coefficient over here, there is no SI unit that appears afterwards. So that's a good indication to whether it is a coefficient or an actual value of friction. If there is a newtons, we know that it is a force, but if there's nothing, just a 0.35 or just a value without, we know that it is without an SI, we know that it is going to be a coefficient over there. She gently pushes on the book with a force that is parallel to the desk top. Calculate the maximum value of the force she can exert for the book to just begin to move. So we're looking about at the amount of force that we can, the maximum amount of force that we can put just before the book is about to move. Right, so the first thing, and you notice I've underlined 800 grams, is because grams over here is not the correct SI units. We need to convert it to kgs. So it's 800 divided by 1,000. Now, if you cannot convert it to kilograms, if you did not do this in the start, you know that everything else is going to be wrong. If you guys want to have a go at this using these formulas over here, you're more than welcome to assist you in the start. Pause the video and then have a look afterwards. Right, so here I have all my different formulas. My mass times acceleration to my y is equal to 0 over there because the book isn't moving yet. There is no velocity or there is no acceleration. And remember, when the book is not moving, there is no constant velocity. There is no velocity. And if there's no velocity, that means my acceleration is 0. And anything multiplied by 0 is going to give me 0. And remember, my 0 over here also falls for constant speed. If I have a constant speed, it means that acceleration is equal to 0. So if acceleration is equal to 0, that means when I say MA, that means MA is equal to 0. And what is MA equal to? F net. So F net is also equal to 0. So that's what we're saying over here. MA to my y is equal to 0. But we also know that Fn minus mg is equal to my value for my F net over here. Right, so all I'm going to do is I'm going to take my mg over, then you have the value for Fn is equal to mg. Now this one over here, please, is important. Whenever I'm talking about Fn, you'll notice automatically I go straight away to my mg, which is my mass times my gravity. Right, let's go back to this one over here. I am looking for my force of max over here, my frictional force for max, just before it's about to move. Just before it's about to move. So you can see coefficients Fn. Now, I've got my value for my coefficients. What is my value? 0.35. And my Fn, I don't have a value for my Fn, but I do have my value of mass, which is 0.8 kilograms. and I do have G, which is a constant. So you can see it's 9,8. So 0,35 times my mass times my gravity is going to give me a value of 2,74 newtons forward. That is the amount of friction that is going to be applied just before it can actually move. Notice I put forward because we're dealing with newtons, which is a vector, not a scalar. Right. Okay, gonna go on to the next question over here. Ooh, let's go like this and like that. Okay, we're moving on to the next question here. Right. A box resting on an inclined plane experiences a normal force of magnitude 130 newtons. So I have actually given you a normal force value. Here is the value of my normal force. We don't have to use any more mg because I've already got my normal force. And the coefficient of static friction between the box and the surface is 0,47. What is the maximum static frictional force? Right, so here I've go. Once again, Fs max is equal to coefficient, my static coefficient Fn, which is then going to be 0,47 from this value over here. And my 130 comes from my normal force that I have already gotten. I don't have to use mg because normal force is given. So therefore, I have a value of 61,1 newtons. The maximum magnitude of static friction is 61,1 newtons. All right, now we are moving on to this long behemoth of a question over here. Ooh, it's a long one. Right, a block rests on a horizontal surface. So we know that there's no incline, it's pretty much just flat. See if we can see all this. Yeah. Okay. The normal force is 20 newtons. So I've got a value over there. My normal force is 20 newtons. The coefficient of static friction between the block and the surface is 0,4. That is static friction. And the coefficient of dynamic friction also known as your kinetic friction, is 0,2. So what is the magnitude of the frictional force exerted on the block while the block is at rest? Right, now when the block is at rest, I've already told you that when the block is at rest, where did I put it? When the block is at rest, we know that there's a constant speed. What is it? It is literally not moving. It's at rest. There's a constant speed of 0. 0, acceleration is 0. There, all of these are going to be 0. Right? So, if my block is at rest, that means for A, I'm going to have a value here. The block is not moving, so there is no kinetic frictional force. The block's not moving. I have not even overcome static friction. So there's no way that I can even have a kinetic frictional force yet. Ooh, I've moved everything. Just adjusting it. Right, then B. What is the magnitude of the frictional force B if the horizontal force of 5 newtons is exerted on the block? Now we have a horizontal force, but the object is still not moving. So because the object is still not moving, the block is not moving, so there is no kinetic frictional force. The static frictional force is 5 newtons in the opposite direction. So at least now we have a value of frictional force for my static, but not for my frictional. Right, now we're finally moving into the calculation C. What is the minimum force required to start the block to move? Well, to start the block moving. Right, so I need the block to finally start moving. And what am I going to use? The values you've been using the whole time. Your Fs max is equal to your static coefficient times your Fn, which is going to be 0,4, which you have gotten here from your static, times your Fn, which is 20 newtons, and you get a value of 8 newtons. Now, remember, it is more difficult to push something that isn't moving until it is moving, then it's going to be a lot easier. So generally, your static friction should be higher than your coefficient of kinetic, your coefficient of kinetic. Yeah, so you can see your static friction is 0.4 and your kinetic is 0.2. So yes, it is true, which also means you need less force to push it. I need less force to push my object. So D, what is the minimum force required to keep the block in motion once it has started? So once the object is moving, what is the least amount of force that I need for it to keep moving? And here you can see, once again, I use the same values, but I'm going to have a different, the same formula, but I'm going to have the different value for my coefficient, because now it's 0.2, not 0.4. I have overcome this over here, and now I need less energy to actually keep it moving over there. All right. And that is going to be static and kinetic friction. Thank you.